Hello and welcome to today's lesson. We are starting chapter 5. So when we're starting chapter 5, this first thing we're going to do is an investigation. So grab your ruler and just make a segment. So I'm going to do mine all freehand here and just make segment AB. Then, to the best of your ability, use your ruler, find the midpoint of this, and then using maybe the edge of a piece of paper or your ruler or something, I want you to find the perpendicular bisector. So that line needs to go right through so that this point right here is the midpoint, so that AM is congruent to MB. And then on top of that, line needs to come down perpendicular. Now just eyeballing it, it kind of looks like my MB is a little bit longer. So I just might make this a little bit longer over here and call that point A. Okay, now that you have that, pick a point, any point. It doesn't really matter where you pick this from. So pick a point P. And then now I need you to measure from P to A. And I need you to measure from P to B. Okay, so measure from P to A and measure from P to B. Okay, and now you should be able to get a conjecture. Okay, what did you find out about those two things? And you should have probably found out, so make sure you stop the video, do everything you need to do, and then come on back. But you should find out that PA is congruent to PB. Now, if you do another point here and call that X, XA should be congruent to XB. And if you do another one down here and call that N, NB should be congruent to NA. What's happening is we're putting a point every single time that's on the perpendicular bisector. And a point that's on the perpendicular bisector is always equidistant from the two sides. So that's what we're talking about today, perpendicular and angle bisectors. So we just did an experiment of this first one. So now the second one's a little bit harder to do because you guys don't necessarily have the right tools. But if you look at this pink line here, this pink line, picking your point, when it comes down, this has to be a right angle. So when this comes down, it needs to be made at a right angle. So again, the two greens are congruent. And when this comes down, these are perpendicular. So any point on the angle bisector is equidistant to the sides. And remember, when we're talking about this distance, it's always the shortest distance at a right angle. Okay, so it's not talking about from this point right here comparing to this one, because this one is not at a right angle. Okay, so it's from whatever that point is at that right angle. All right, so equidistance means that it is the same distance from two or more objects. So remember, anytime you need to pause, stop it, and then go ahead and copy things down in your notes. All right, so this is the one you should probably be stopping and pausing and copying down. So what this is saying, the perpendicular bisector theorem. If a point lies on the perpendicular bisector, okay, point C is on that perpendicular, this is your perpendicular bisector because it is coming through at the midpoint and it's perpendicular. If a point C is on the perpendicular bisector, then it is equidistant from the endpoints. So AC is congruent to CB. So that's what this part says. Then CA is equal to CB. Okay, so now go back to chapter 2 and think about in chapter 2 when we did converses. So the converse is, if a point is equidistant, see how this point D is equidistant to point B and A? Then what we're saying is D must lie on the perpendicular bisector. All right, so let's try some examples. All right, is this a perpendicular bisector? Is this a perpendicular bisector? Yep, perpendicular, sides are marked congruent. So how long is RT? Well, those two distances must be equal. So this has to be 16. All right, AB. All right, they're telling us that this is congruent. It's on the bisector. It is perpendicular, and if these are, so it must be. So this is also 2.5. So what do they want? AB. So this must be 5. All right, HJ. First thing I'm checking is perpendicular and bisector. So we're good. Okay, so 3x plus 1 must be equal to 5x minus 3. You always have to make sure that you write that algebraic statement. Now go ahead and solve however you need to. So I'm going to subtract 2x from both sides, and I'm going to add 3 to both sides. So it looks like, whoops, I'm going to subtract 3x from both sides. 3x minus 3x cancels. 1 plus 3 is 4. 5x minus 3x is 2x, and that cancels. So now let's divide by 2, and it looks like x is 2. So they want to know how long HJ is. So we're going to go 3 times 2 plus 1. So it looks like we're going to get 7. Okay? All right, is this a bisector? Okay. Is this line L a bisector? Sure is, because this is 3 and this is 3. Yes. Is it the perpendicular bisector? Well, we don't necessarily need this to have the right angle mark if these two pieces are congruent. But they are not congruent, so this is not a perpendicular bisector. Those two numbers in the boxes would have to be equal. All right, now we're talking about the angle bisector. Okay, this AD is for sure an angle bisector because we have a single mark and a single mark. So they're saying any point D, as long as it goes to the side perpendicular to measure that distance, perpendicular, then these two pieces must be equal. Okay, remember, if I just put some random point in there, DW is not equal to DC. Why? Because DW does not come down at a right angle over there. So they have to come down perpendicular. Okay, now the converse of this is going to be, if a point is the interior angle, D is in the interior of the angle, and it is equidistant from the sides. How do I know it's equidistant? Because it comes down perpendicular. If it is equidistant from both sides, then we can conclude that D is on the angle bisector. Okay, if those two distances are equal, then it has to be on that angle bisector. All right, JL, let's see. JL is bisecting HJK. Okay, so we know that, so these are equal. And if LK is 11.4, then LH has to also be 11.4. All right, LH, and okay, now they're telling us that both of these are 26. So if they are 26, they're telling us L must be on that angle bisector. So HJK is 122. What do they want to know? LJK, they want to know this angle in here. So we're going to take 122 and divide by 2. So what do we get? Is that 61 degrees? All right, let me change colors for this last one. So they're telling us that LH and LK are congruent. HJL is 3y plus 19, and LJK is 4y plus 5. Okay, well, these must be on that angle bisector, so that means that 3y plus 19 has to be equal to 4y plus 5. All right, I'm going to subtract 3y, and I'm going to subtract 5, so it looks like cancel. what's that? 14 and y. So y is 14, and that's all they ask us to find, is that value of y. All right, think and discuss. Suppose that M is in the interior. Okay, we got M in the interior, and MJ is congruent to ML. Is M on the angle bisector? And the only way we would know that for sure is if these are perpendicular, and there's nothing here that tells us they are perpendicular. So I would have to say no, we do not know that for sure, because we don't know that these are the actual distances and that those angles are right. All right, this is the big thing. We've had one of these on like 4 different assessments. You absolutely positively need to know how to do this. So please take out a piece of paper, pencil, make sure you write this down. Write an equation, and this one's in point slope, so we're going to write this in a little bit different a form. I'll probably do both just because. The perpendicular bisector of PQ. Okay, so what they're really asking me to do is write the equation of this green line. To be the perpendicular bisector, it has to be perpendicular, and that must be at the midpoint. Okay, so I am going to find the midpoint of PQ. So to do that, I'm going to take 5 plus 1 and divide by 2, and 2 plus a negative 4 and divide by 2. So what's that? 6 divided by 2, so I get 3. 2 plus a negative 4 is negative 2 over 2, so the midpoint is at 3, negative 1. All right, so one way is y equals blank x plus blank. Now I need to find my slope. So I'm going to find my slope of PQ. So I'm going to take my 2 y values and subtract them. 2 minus a negative 4 and 5 minus 1. So this is 2 plus 4 is 6. 5 minus 1 is 4. So we get 3 over 2. So the blue line slope is 3 over 2. So what is the slope of the green line? Remember, we flip it and make it negative. So we flip it and make it negative. Now to find the y-intercept, I'm going to plug this point in here, x and y. So y is negative 1. X is 3, and I'm going to solve for b. So these 3's are going to cancel. Negative 1 is negative 2 plus b. Add 2, add 2. So this is going to be 1 equals b. So make sure you go up and finish your equation. That would be a 1. So the equation of the green line is y equals negative 2/3 x plus 1. Now they want you to write it in point slope, so pick a point. I'm going to use point P. So this is going to be y minus 5 equals my slope, negative 2/3 x minus 2. So that would be my point slope form of the equation. Y minus 5 equals negative 2/3 times x minus 2. All right, I think we're at the end of the lesson. Yep, it is homework time. So good luck on your homework.